Is this you? Measuring a catheter apart with a ruler or a yardstick? God forbid should this be actually for production. I've seen it happen. You know and I know you will never pass gauge R&R with this with a plus or minus half millimeter tolerance. So why are you doing it? Common answers, this is how we've always done it. Or the other one, we don't have any alternatives. Now you do. This is the River's Edge Engineering and Design Measurement System. It combines a camera, a digital readout, and a monitor to be able to measure parts without touching them visually. Why is this a good thing? I can take my part, put it in a V-tray that's consistent, and measure it every single time. Okay. Did I mention I can also set my tolerance zone? So if I butt my part up against this end and move it down so it's on that end, so my part is there, I can move these lines on the line generator with this remote. I can change the colors, make them dash, whatever you want. I can have 10 lines vertical. I can move these lines to where my lower tolerance is and my upper tolerance. So now this is my high and low and my nominal part, or my nominal length. The result is I no longer have to measure the part. I just have to make sure that this end of the catheter is between this guy and this guy. So right now, this would be a good part. That's very, I can do attribute and variables data. Pretty slick. This will measure down to 5 microns. Really, really small. The camera is high definition. I can even take photos with it if I want. Pretty slick. It just prompted me to put an SD card in. I'm not going to right now. Did I mention you can also use this for production? I currently have a hardwire cutter. This will cut stainless steel, nitinol, copper. It's a very easy to obtain side cutters mounted on basically a little block. This block is a hard stop. It's big because it has to take up the space and allow room for other tooling to be able to be bolted in. I'm not going to bolt this in right now because you don't need to see me do that, but it's basically a couple quarter 20 screws, bolts in, put your part in here, make sure the other end of the part is in between your lines of whatever you want for a tolerance and length, and I basically cut my part. So that's really slick. Other addition that I have for this guy for manufacturing end of it is a roll cutter. Pardon the junk in the background, but that's what happens when you work in your shop. So this is a roll cutter. Put your razor blade in between the dowel pins, standard roll cut. So it's got a couple ball bearings and a couple rollers. The plus about this guy is these rollers are actually adjustable height. So as you have a smaller and larger diameter catheter or part in here, the tangent point of that said part changes. And so where it will contact the rollers changes as well. So what you do is you adjust this little stage back and forth, and these rollers actually move up and down to accommodate the different size or different diameter part. So you have a one size fits all roll cutter that no longer has, basically the catheter will not be doing this or doing this when you roll cut. So let's try this thing out. So we're just going to measure this random catheter made by whoever. So let's call that 0. I'm doing this one-handed, so please bear with me. So call that 0. So we're going to set this to 0.0. Enter. Sounds good. Let's measure the length of this part. So we go down to the end and call it good. We are 588.27 millimeters long. That's pretty slick. Once I know what my overall length of the part is, I can zero out on this end. I can teach you how to do that and put your part up against a hard stop. Go to this end, leave this guy on that end, and you will take your inspection time for long parts from hours to minutes. As fast as you can put them in the V-tray and look at the screen, you are done. We've got a nice little ring light, so everything pops really nice, easy to see, easy to clean, easy to use. My 10 and 12-year-olds can use this thing all day long. In addition to what we have, the other parts that I've shown you, this is a magnetic clamp that is basically an adjustable end stop. So I take this guy and, again, fumble around with one hand because I don't have an assistant right now. The magnets are strong. Anyways, so this basically clamps onto here. You can adjust this guy back and forth to accommodate when you're over top of these, and zero off on this, and you can move this guy around, and now you've got a hard stop. Other things that I offer is these little brass blocks. They're stupid, they're easy, but what are they? So all these different little notches on the sides can hold like tubing and stuff that has a tendency to want to curl. You basically put it in the V-tray, put this down, and it holds it down so it stays straight all the way down. So you get about a half dozen of these things, and you can measure just about anything. And they've got like all sorts of different sizes to accommodate all sorts of different diameters. Bigger ones and smaller ones available as well. This is a really slick machine. I don't see how you can't not have this in a production world or contract manufacturing. This is a game changer. When you are trying to save seconds off of commodity parts such as pull rings or wires or whatever, and you're making these things by the thousands a day, and you're spending hours a day inspecting them to make sure that they're in tolerance, this is a game changer. This saves you a lot of time. Talk to me, River's Edge Engineering and Design, and we'll get you set up. Talk to you later. Bye-bye.